Hello there, we're going to look today at a Year 12 further maths topic, which is actually very similar to one you did at GCSE. At GCSE you got asked to draw scatter graphs, a bit like this thing here. This is meant to be a scatter graph. And at GCSE very often they ask you to draw a line of best fit through the points. So here's my attempt, or someone's attempt at least, to draw a line of best fit through these blue points. And you can see there's a few above the line. And a few below the line, and the idea basically is meant to go through the middle of the points, and sometimes it goes to the origin. Notice this one doesn't. This one goes just above the origin. And I suppose the sole difference with A-level further maths is that we try to find an equation, and this is my attempt at an equation, or someone's attempt at an equation. Y equals so many x plus a number, and that number comes about from the fact that it doesn't go through the origin. Now how we get this is called the least squares regression line, and it's sort of an attempt to be more precise than just it kind of goes through here, kind of goes through there. So look, before we get onto that, here is a starter. Now this was a topic that we saw in exercise 5b. It was a topic called Spearman's rank correlation coefficient, and not only do you need to be able to find Spearman's rank correlation coefficient, usually written RS, you have to find this, but you also need to do a test. So you'll need to write H0 out, write H1 out, and then decide whether or not, in order to test this, you're going to have to find the critical value from the table, and then determine whether or not to reject or not reject H0. Now, I'm not going to give you any clues more than that, other than I'd recommend you pause the video now. So look, I hope you have gone away and done this, because that's the whole point of these videos, is that you do practice these things. Look, this is what I got. There we go. So by the way, the H0 should have said no association between these two things, whereas H1, it should be test whether there's a negative association. There you go. So it's a one-tailed test, I suppose. So anyway, test for this negative association between these two things. And that's obviously these two judges are deemed to be in complete disagreement with each other. But it seems that this, when you do this, your critical value is 0.690, but a negative version, so that is negative. And your critical value is more than that, 0.7381. Notice I don't care about the minus signs when I do these tests. So that is less than that, therefore I do not reject H0, and there's a wordy bit as well that goes with it. So look, hopefully you're good at that. Now I want to do the least squares regression line, which is the whole point of this video. So this is, as I already said, the posh version of a line of best fit, least squares regression line. Sometimes called linear regression as well. Now, if you was asked to draw a line of best fit through these, as I've already said, it doesn't have to go through the origin. You know, exactly where you draw it, you try and get the same number above and below, something like there. So you might, for instance, see that and think, no, that's not bad, it's pretty close. Now, I suppose what I want to do is talk about residuals. Residuals are important when you talk about this least squares regression line. So a residual, as it says, is the vertical distance of each point from the line of best fit. So you know, it's a little bit over there. So my point is a little bit above my line, whereas here my point is a little bit below my line, and you can do the same thing. So if I show you the residuals, this one you can see is my point is below my line. This one, my point is below my line, but then, you know, that one's above, that one's below, and they've got this tiny little thing here. And you do that for all your points. And I suppose what we do is we try, where possible, to make these gaps between the points and the line as small as possible. I suppose the total of all those gaps, the total of all those residuals. And so if I was doing this, for instance, I could work out these residuals. So if I just do this now, my point here is apparently 20 across, 30 up. Here it is. And my residual, now you can do this either way, and my value of my line, I'm going to suggest, is a little bit under. I'm going to say it's 29. So if I do my yn, my 30, minus my actual value, 29, from my line, you can see I've got a residual of 1. And if I do my 50 value, well, where's my 50 value? Oh no, it's my 40 value, which is 50. That's right. 40 value is 50. Well, I reckon my line here is exactly on 60. It seems to be exactly on 60. And if I do 50 minus 60, I get minus 10. And what's at the 50 point, it says 85, but my line is more like, I reckon that is 76. I don't know exactly what it is. So 85, I reckon that's 9 out. So take it away 1 from there, I get 9. Now the next one, the 70 point, well, my line is way above this 70 value. It's actually more like, I reckon that's like 91. So that's minus 21. And then 70 across has apparently a point of 100 on the point there, but actually my line is more 108. So all I've done there is, you can see 70 minus 91, 100 minus, yeah, so that's minus 8. So if I just add those up quickly, I think I get minus 29. So let's see. And I suppose what I'm trying to do here is say to you, minus 29, according to me, is as good as it gets. And from these numbers, from these as small as possible, effectively I end up with an equation. And according to me, and I just saw one pop up just now, this is the equation. It says it is 1.33x. So if you like, this is like a gradient. This is like y equals mx plus c almost. And this is like my y-intercept. My y-intercept. Now, what's it on? So that's, yeah, that hits about, it says 3 and a bit. So yeah, we can go with that. Now, I suppose the big question is how good the residuals are for this compared to what I got. Now, I got residuals of 29, I thought. What did I get? Let's just go back and have a look at that slide. Minus 29, so my residuals were rubbish. So they reckon this has even better residuals and of 0.25. That's, I mean, 0.25 is almost perfectly minimizing up and down values. Now you have to take my word for it, it's 0.25. I'm not going to go through all that again. But look, this regression line then is meant to get the best possible line of best fit through these points, and it reckons it does that by minimizing these residuals. Look, there are two ways to do it. There is, first of all, we can use our CASIO or Texas or whatever calculator you've got to do these for you. And literally you can type the numbers in and it tells you the answers. Sometimes you can't, you're given the summary statistics, and you have to then use the formulae. This is a brief summary of how to use the two different calculators. The one I've got in front of me today is the CASIO classwiz, so that's the one on the bottom, and that's the one I'm going to be using today. But you can use whichever one you've got, but obviously you're going to need to suss how to do it on your calculator. So if we've got these numbers, I'm going to type them in. So it says basically find the least squares regression line y on x for the following data. So okay, first of all, now we'll just go back a bit. It says press menu 6. So menu 6, and then it says press the 2, the a plus bx, and it tells us to enter the numbers. Okay, so I've done that. So let's go and enter the numbers. And you enter the x numbers first on this. So 1, 3, 4, 6, 8. 9, 11, and 14. And then, having typed all those in, I go back to the y column, and then I put those numbers 1, 2, 4, 4, 5, 7, 8, 9. They're in. So what does it tell me to do then? Then it tells me to press Option, and then it tells me to press number 4, Calc, Regression Calc. So we've talked about least squares regression, so I'm not surprised it's regression calc. And the great thing is it just tells me the answers. Now notice this formula here. It says it on the screen actually. It says the answers you're going to get is a plus bx. And actually on the screen it says y equals a plus bx. So it tells you what these values are. So it says y equals a plus bx. But then on my screen it tells me that a equals 0.54. And a bit, so I'm going to 0.545, I'm going to write them to 3 sig figs, plus b, what's b? It's 0.636. X. And that's as easy as it is. That's my answer, hopefully. There it is. And it is exactly that. You can just type these in. So next example, let's type them in. So same job, menu 6, 2 again, I think it was. And now I'm going to type these numbers in. 20, 28, 22, 15, 18, 25, 19, 16, 17, and 23. Now the Y numbers. Okay, they're in. So now I press Option and 4. And what have I got? I've got, well, obviously I know it's y equals a plus bx, so my a this time is 31.6. Notice I didn't even read what the question was about. I should have done really, but I really didn't care too much. Plus b, that was actually a negative number, so I suppose I just write minus 0.963, I think it is, x. Let's see if those numbers are right. Yes, they are. And it then says, hence, estimate the values of y for x equals 12 and x equals 21. So obviously, I substitute these in. So put 12 into there and get an answer, and then put 21 in there. So when x equals 12, I need a y value, and when x equals 21, I need a y value. So I can do that quickly. Menu 1, go back to the start, menu 1. So what is it? 31.6 minus 0.963 times 12. Press SD, I've got 20.0. And if I do it for 21 as well, 31.6 minus 0.963 times 21. 11.4 I'm going to write to 3 significant figures. And it says, which of these values is more reliable? Now, I suppose it comes about from the fact that my original x values went from 20, 15. They go from 15 at the smallest value up to 28. So because they go from 15 to 28, 12 is outside that. So I think that's the best answer. This one's the best answer. What do they say here? The first answer is not reliable since 12 requires extrapolation. Now, extrapolation is a posh way of saying you've had to extend it beyond the numbers that you started with. But the second one's much better. So on that basis, let's look at this. Now, look, I've so far just showed you how to type them in. You do get questions where you have to type them in, but you also get questions where you have to actually calculate your values of B and your values of A. The actual easier one to calculate is B. And we've seen these formulas before for SXY and SXX. We saw this on Pearson's product moment correlation coefficient, exercise 5A.1 and 2, I think it was. So please go and have a look at those. But so those are the formulae that we've used before. SXY has actually got a posh name. It's called the covariance. But basically, we've seen these before, and you actually won't need the SYY for this. It's just the XXY and the SXX. And look, this is a slightly harder one. To get the A value, I personally use this, we've seen before, Y minus Y1 equals M x minus x1. So I just reimagine that in terms of A's and B's and stuff. And I write Y minus Y bar equals B x minus x bar. Now, the x bar, Y bar trick comes about from whenever you draw your scatter graph, your line of best fit, your least squares regression line, if you do it properly using the least squares regression line, will always go through this, what I'm going to call the mean point, x bar, y bar. And knowing that really helps. Now, a boy decides to count how many Christmas presents his classmates gave him and how many he received. Oh, how many he gave. So notice the sense of this question. Now, we're not going to be able to do it now because I'm more or less out of time. I perhaps will do a second video. That might be a good idea. I'll do a second video on this, and then you can see how it works. So for now, we can do the calculator buttons. We've seen the formulas, but we really do need to have a look at this to make sure we can do the formula questions. Okay, thank you very much.